Hello, Honors Algebra students. Mr. Lawrence here, and you're going to be learning how to graph linear inequalities. And this is pretty easy stuff, ladies and gentlemen. Pretty easy stuff. Now, it's so easy, I think you can learn it just from this video, and you won't even need much practice time in class. Of course, you can come see me or email me or let me know what's going on. Don't just email me and say, I don't understand. You have to tell me what you're not getting, okay? Well, let's get down to this, shall we? All right, first of all, I've got this inequality that looks an awful lot like a slope-intercept form equation. Yeah, and so I'm going to pretend it is just that. I'm going to find the y-intercept, which of course is 0, -4, right? And then I'm going to find the slope, which is 2 over 1, and I'm going to rise 2 and run 1. Okay, now, because this is an inequality though, I'm not just going to graph the line. There's going to be a little bit more to that. Remember when we did inequalities on number lines, we always had a shade because more than one number made it true. Like when we solved an equation, we only got one answer, right? But in an inequality, there could be infinite answers, and sometimes they took up a whole region. Well, this is something similar. So the first thing I'm going to do, are you listening to this? Jordan, did you hear it? First thing I'm going to do is I'm going to check and see if there's an equal sign. If there's an equal sign. If there's an equal sign, I'm going to make a solid line when I draw it. If it's only a greater than or a less than, I'm going to end up drawing a dashed or a broken line. Why do you suppose that is? What's that, Lucas? Yeah, you're exactly right, Lucas. Because if it's not equal to, then these points that I plotted won't be a part of the solution set. Isn't that cool? Because remember, isn't a line, we really don't graph a line, we graph the points, and the points are the solutions. So we're really graphing all the solutions to the linear equation. Well, in this case, if it's not equal to, this one is, but if it's not equal to, then the points we plot to get the shape of the line, the direction, those will not make the inequality true. Now this one happens to be equal, so they do make it true. So when we graph our line, we are going to use the solid line. Okay, and let's see, it's going to go down 2 and back 1. And it's going to go like this. Now, it looks like we're done. And some of you that rush through stuff are going to go, I'm done. No, you're not. You're not done. Because it's an inequality. There's shading involved. There are a whole bunch more answers than just the points that are on the line. There are other points. They might be above the line or below the line. Well, here's how we're going to find out. We are going to use a test point. We've got the inequality y is greater than 2x minus 4. And you know, Mr. Lawrence, for a test point, I love to use 0. Well, since I need 2 coordinates, I'm going to use the origin. The only time I cannot use the origin is if the line passes through it. Did you catch that? Morgan, did you hear that? The only time I cannot use the origin as my test point is if my line passes through it. If my line were going through the origin, I would pick a point like 1, 0 or 0, 5 or something like that where the math would become very easy. So my test point is going to be 0, 0. I'm going to plug 0, 0 into this inequality. If I get a true statement, I will shade the side of the line that the test point is on. Yeah. Because if I plug in any point on this side and I get a true statement, it needs to be in my solution. So I'm going to put 0 in for y, that greater than or equal to 2 times 0 for x minus 4. I'm going to simplify the right-hand side, and if this statement is true, then I will shade the point. Is 0 greater than -4? It sure is. So I'm going to shade everything over here. Any point you pick on this side of the line will yield a true statement, guaranteed. If you like, I'll pick a point on the other side of the line and I'll show you how it ends up being false. Okay, so let's see here. Let's pick a point on the other side of the line. Let's pick 10, 0, just to make the math easy. So y is going to be 0. Is 0 greater than or equal to 2 times 10 minus 4? Nope, not at all, because that's going to be 20 minus 4 is going to be 16. 0 is not greater than 16. So I won't shade that side. That's pretty easy, huh? Now the biggest problem is some of you go, oh, I know how to graph a line, and you go, dude, I'm done, and then you won't stop to consider shading, or whether the line needs to be broken or solid. All right, check this one out. There's two things I noticed right away. One, it's in standard form, and two, look at it right here. There's no equal sign. This is going to be a broken line when I go to graph it. All right, so since it's in standard form, I'm going to sing. Oh, I don't want to be in highlight mode. Sorry about that. I'm going to sing. Are we ready to sing? All right, sing to me, class. A, B, C. Easy as 2, -5, 8. And I think I'm going to find the x-intercept. The x-intercept is going to occur at 4, 0. Right? 4, 0. And I don't like the y-intercept because it's not coming out to an integer or a whole number. And so I will use my slope, which I believe will be 2/5. Right? -a over b. So I'm going to rise 2 and run 1, 2, 3, 4, 5. And I can go down 2 and left 1, 2, 3, 4, and 5. There we go. All right, now it's not equal to, so I'm going to use a dashed or a broken line, something like this one here. And let's see, I'm going to go from there to there. Yeah, it looks kind of cool, doesn't it? All right, make him a little bit longer. And now I want to use my test point. Can I use 0, 0? You better your life, right? Because the line is not passing through the origin. So I'm going to go 2 times 0 minus 5 times 0. Is that less than 8? And so you're going to get 0 is less than 8, which is true, which means I will shade the origin side. Now I'm not going to go and test it again on the other side. I'm going to trust my math and check for mistakes, etc. But it's going to be all of this. Every single point on this side of the line will result in a true statement in the inequality. Yep, there we go. Okay, let's see here. One more example, I think. And whoop, it's standard form again. It's not equal to again. So I guess it's time to sing. And so let's go A, B, C. Easy as 4, -3, 9. Right? And so the y-intercept is up here at 9. Okay. My slope is going to be 4/3. I'll go down 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 2, 3. There we go. It's going to be a broken line. How do I know it's broken, Jared? Because it's not equal to. It's not equal to. Did I mention it wasn't equal to, and therefore it's a broken line? Yes, I believe I did. Okay. Now, I got to do my test point. I can use the origin. Why? Because 0, 0, the line does not pass through 0, 0. So I am going to do 0, 4 times 0, that is, minus 3 times 0. Is that greater than 9? Well, left-hand side is 0 is greater than 9. That is a false statement, and so therefore I will not shade that side of the line. I will shade the other side. All right. And there you go. That's it. You just learned how to graph inequalities. All right, I'll tell you what, I'm going to go ahead and assign the homework too. It'll be Excel 6.5, I think it is. All right, I'll assign that to keep you guys busy this weekend. All right, Mr. Lawrence signing off. Have a good night, everybody.